Hello, this is Maria from Mammoth.com. In this lesson, we're gonna review some basics about equations and how to solve simple equations. So what is an equation? Well, an equation is just very simply an expression on one side of an equal sign, and then some other expression on the other side. Could be just most anything. So here's one equation. It contains some variables. Here's t and x and y. But an equation does not have to contain a variable. It could be, for example, 2 equals 5 plus 17. That's an equation, technically speaking. We have an equal sign and an expression on this side, expression on the other side. Now, this last one that I wrote happens to be a false equation. There's no true equality there, because 2 does not actually equal 5 plus 17. So what is the root of an equation? That is the value of a variable that makes the equation true. For example, if I have t plus 2 equals 1, then a certain value of t will make this equation true, and that is -1. Okay? -1 plus 2 equals 1. So -1 is the root. Now, let's check, is t equals 0 a root of this given equation here? 5t squared plus 2t minus 7 equals 0. To check if t equals 0 is indeed a root, we'll just substitute 0 in place of t and check if we get a true equation or a false equation. So we have 5 times 0 squared plus 2 times 0 minus 7. And is that really equal to 0? We're checking. So I put the question mark here. This is 0, 0, and then -7, and then 0 on the other side. Well, clearly, -7 is not equal to 0, so we did not get the true equation. So then 0 is not a root of this equation. To solve an equation, we will perform the same mathematical operation to both sides of the equation. In this process, we try to isolate the variable, so that the variable is left alone on one side. In this example, 24 minus x equals 2 times 17. What we want to do first is actually simplify this side and just calculate that there's 34 here. So we did not yet do any operation to both sides, but now we will. We want to isolate x here. It's actually minus x. And there's 24 added. This is actually plus 24, right? So to isolate x, we need to get rid of this 24, and we subtract 24 therefore. I'm going to mark it here in the margin, so to speak, that now we're going to subtract 24 from both sides of this equation. And that leaves then minus x, negative x, and on this side 34 minus 24 leaves 10. And then the next step, well, you can probably see already that x must be -10. But if we want to mark an operation that we do, we could say that we multiply both sides by -1, and then that leaves x equals -10. In this other example, we have a fraction, 2/5 times y equals -8. And so the standard thing to do with fractions is to multiply the entire equation by the denominator, because then we will get rid of the fraction and it's easier to solve after that. That's not the only way you could start solving this. You could start solving it by dividing by 2 or multiplying by 5/2. But let's do this. So this whole thing times 5 then becomes 5 times 2/5 times y. Then on this side, 5 times -8. On this side we get -40. Over here, 5 and 5 cancel out, and then we are left with 2 times y, or 2y. Then after that, I will divide both sides by 2, because there's 2 times y here. And then we are left with y equals -20. At this point, when you get your root, it's good to check that the root is indeed a root, and substitute it back to the original equation and check that you have a true equation. So if we take -20 and put it over here in place of y, imagine that we have 2/5 of -20, this calculation here. So that would be 2 times -20 is -40 divided by 5. Yes, that equals -8. So it checks. All is well. Lastly, is this solution to an equation correct? Think about it for a while. Okay, even without checking all this process here, we can just take the root, -1, substitute it here and check. Are we going to get the true equation? 12 minus 3 times minus 1. Is it gonna be negative 15? 3 times minus 1 is negative 3, but then we get the 12 minus minus 3, right? The double negative. And that is definitely not negative 15. 12 minus minus 3 is actually 15. Positive 15. So there's something wrong. Something went wrong with the equation, with the solution. Let's now analyze this whole thing. What went wrong? We have 12 minus 3x equals negative 15. And it looks like if you subtract 12 from both sides, it looks like the student calculated across sides 12 minus 15 equals negative 3. That's what they did. So that's one thing that's wrong with this solution. But there's another thing also. And that is that if you subtract 12 from both sides, then there should be negative 3x left on the left side. So let's just redo the whole thing. Okay, here's our equation. And we subtract 12 from both sides. So we have negative 3x or minus 3x left. And on the other side, negative 27. Minus 15 minus 12 is negative 27. And then we divide by negative 3, both sides, and get that x equals 9. Let's check, does it work with the original equation? 12 minus 3 times 9. 3 times 9 is 27. 12 minus 27 equals negative 15. That checks. Okay, everything is good now. All right, we're all done with this lesson. I hope it was helpful.